All right, using Pascal's triangle for polynomial expansion. What in the world is polynomial expansion, first of all? Well, if I give you a problem that says x plus 3 to the fourth power, and I tell you to expand it or multiply it out, you would be multiplying this binomial times itself 4 times. Now, you can do that. We've done that. It's not that it's difficult, it just takes a lot of work. There are a lot of steps. Okay, so there is something called Pascal's triangle that we can use to help us. And this is what Pascal's triangle looks like. This top row right here starts with the number 1. The next row is made up of 2 number 1s. And then you go to the next row. We start with a 1. And to get this middle position right here, you're going to look up and left and up and right. If you add these two terms together, you get the number 2. And then you finish with a 1. Next row, you start with a 1. To get this next position, you look left and right. 1 plus 2 is 3. To get the next position, you look up, left, up, right again. 2 plus 1 is 3. And then we finish with another 1. All right, next row. Start with a 1. To get your next position, 1 plus 3 gives us 4. To get the next position, 3 plus 3 gives us 6. To get this next position, 3 plus 1 gives us this 4, and then we finish with a 1. And you can keep going over and over and over again. Just recognize that we always start and finish with 1s, and then you can fill in all of these blanks in the middle just by looking up, left, up, right, and adding those values together. Now, when you are labeling these rows, this top row we call row 0. It's not row 1, it's row 0. Now that's important. This is row 0. This is going to be row 1, row 2, 3, 4, 5, and so on. You could have infinitely many rows, okay? So because this problem that we have down here is x plus 3 to the fourth power, we are going to use row 4. We're going to use row 4. Now, what do those numbers mean? Those numbers represent the coefficients of all of the terms in our expanded solution, okay? So this is what it's going to look like. Let's do this. I'm going to put the number 1 as my first coefficient, and then I'm going to have the rest of my term here in this blank. Plus, the number 4 is my next coefficient with the rest of my term in this blank. Plus 6, plus 4, plus 1. Okay, so those are all of the terms that I'm going to have, or the coefficients of all of my terms. Now let's look at the binomial we are given, x plus 3. So I'm going to take this x value right here, and it's going to go to the fourth power. In the next blank, I'm going to have x to the third. So I just subtract 1 from my exponent. Then I'll have x squared, x to the first, and then x to the 0 power, okay? Then I want you guys to take the second term that we have in this binomial expansion. Let's use green. So we have 3, okay? So we're going to start out with multiplying by 3 to the 0 power. So the second term in our binomial we take to the 0 power. Then we're going to multiply by 3 to the first power, 3 squared, 3 cubed, 3 to the fourth. So hopefully you see that pattern, okay? Now, I want you to pay attention to the fact that 4 plus 0 is 4, 3 times, or plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, 0 plus 4 is 4. That can kind of help make sure you've got your right exponents, okay? All right, so now let's simplify this down. Anything to the 0 power is always 1, so 3 to the 0 power is 1. So 1 times x to the fourth times 1, that just tells me my first term is x to the fourth. Okay, our second term, we have 4 times 3 to the first power. So 4 times 3 is 12. So we have plus 12x cubed. All right, let's get a little bit bigger. We have our next term. This 3 squared right here is the number 9. So let's just go ahead and cross that out, put a 9. 6 times 9 is 54. So this is plus 54x squared. All right? Our next term is 4 times x to the first times 3 cubed. Well, 3 cubed means 3 times 3, which is 9, times 3 is 27. Well, what is 4 times 27? So let's do 27 times 4. That gives us 28, carry your 2. It's 108. So plus 108 x to the first power, or just x. And then this very last term, x to the 0 power, again, is just the number 1. So 1 times 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 3 is 81. So here we have x to the 4th plus 12x cubed plus 54x squared plus 108x plus 81. And that is how you can use Pascal's triangle for polynomial expansion. All right, I want to show you guys something else, how you can use your Desmos graphing calculator to help you check your work, okay? So let's go to that calculator right here. And I already have graphed for us y equals x plus 3 to the 4th power. That's the first row here in our calculator. So this is what our graph looks like. It's x plus 3 to the 4th power. It's our cubic function. All right, now if I were to multiply everything out, this is the solution we got. This row 2 is the solution that we got, or the expansion that we got. I turned both of these into equations and graphed them both. And hopefully you noticed that that blue graph graphed directly on top of the red one. That's how you know that you expanded correctly, whether you did this by hand using multiple distribution methods or whether or not you use Pascal's triangle. Either way, we have the correct answer. All right, let's try another problem. What do we do if we have 3x minus 5? So not only is this not just an x variable with a coefficient of 1, we also are subtracting in this problem. So let's see what happens here. I'm going to make Pascal's triangle at the top again. So we start out with 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Now, why did I stop here? I notice this is to the 3rd power. Remember, this is row 0, row 1, row 2, row 3. So I don't have to make or go any further. I don't need any more rows in Pascal's triangle. I've got as many as I need right here. So let's go ahead and box in the row that we need, this 1, 3, 3, 1. So let's use those as our coefficients. So I've got 1, and some more, plus 3, the rest of my term, plus 3, plus 1. Okay, so here we go. We're going to start out with 3x. The first part of my binomial is 3x, but because it's not just a variable, it has a coefficient, I need to put this in parentheses. 3x to the 3rd power. Then I have 3x squared, 3x to the 1st power, and 3x to the 0 power. And then we'll take our second value in this binomial, this -5 or a -5. So I need to put the 5 in parentheses also because it is negative. So -5 to the 0 power, -5 to the 1st power, -5 to the 2nd power, and -5 to the 3rd power. Anytime you take a negative value to an exponent, you've got to use parentheses. All right, so let's simplify this down. -5 to the 0 power is 1. And then I've got 3x in parentheses cubed. That means this cubed needs to go to the 3 and the x. 3 times 3 is 9, times 3 is 27. And then I have x to the 3rd. So there's our first term. Now our next term, this -5 to the 1st power is just -5. This squared goes here and here. So this is 9x squared. And I'm multiplying by 3. So let's see. We've got 3 times 9 times -5. 3 times 9 times -5. Okay, so 3 times 9 is 27. Oops. We've got 27 times 5. That gives us 35, carry your 3, that's 135. But because we multiplied by a negative value, I know I'm going to have minus 135 x squared. All right, the next term, we have 3 times, well, let me tell you this. 3x to the first power is just 3x. If you want to go ahead and rewrite it without your parentheses, you can to make your life easier if it looks better to you. And then I have a negative 5 squared. Negative 5 squared means negative 5 times negative 5, which becomes a positive 25. Okay? So here we go. We're multiplying 3 times 3, which is 9, times 25. How much money do you have if you have 9 quarters? 25 is like a quarter, right? If I have 9 quarters, that's $2.25. So it's 225. So plus 225x. And then our very last term, we have 1 times 3x to the 0 power, which of course just becomes the number 1, times negative 5 cubed. Negative 5 times negative 5 is a positive 25, but then when I multiply by a negative again, I get a negative 125. So when I multiply these values together, 1 times negative 125, we just get minus 125. And there is your expanded solution. 27x to the third minus 135x squared plus 225x minus 125. Okay? Now, you might still not be convinced that using Pascal's triangle is worth it. Maybe you like double distribution or triple distribution or whatever. Let's go to something with an even higher exponent. If I give you 2x plus 5 to the 5th power, multiplying 2x plus 5 times itself 5 times seems like a lot to me. So let me go ahead and make Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. How many rows do we have? Row 0. Row 1, 2, 3. I'm only on row 4, and I've got to go to row 5. So let's do one more row. 1, 5, 10, 10, 5, 1. Here is row 5. This is what I need because my binomial is being taken to the 5th power. Okay? So let's do this. I've got 1 and the rest of my term, plus 5 and the rest of my term, plus 10, plus 10. I'm going to go down to the next row, plus 5, plus 1. Okay? And I did that because I want to make sure that I have enough room to have everything written out and not squeeze it all together, okay? So I start with my 2x, the first part of my binomial. I'm going to put that in parentheses and take it to the 5th power. 2x to the 4th power. 2x to the 3rd. 2x squared. 2x to the 1st. And 2x to the 0 power. And then we have the second part of our binomial, this 5. So I'm going to multiply by 5 to the 0 power times 5 to the 1st. 5 to the 2nd, 5 cubed, 5 to the 4th, 5 to the 5th. If you want to always put your terms, both of them in parentheses, just so that you don't make that mistake or any mistake, that's fine too. I could have put all of those positive 5s in parentheses before taking them to a power. So it's just a preference there. All right, so let's simplify this down. I have 1 times 2x to the 5th times 5 to the 0. 5 to the 0 is 1, and this 5 needs to go to the 2 and to the x. 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is 32x to the 5th. All right? So our first term is 32x to the 5th power. Our second term says 5 times 2x to the 4th times 5 again. All right, so let's multiply that. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 16x to the 4th power. Now, I like multiplying by quarters because I know how to count money, right? 5 times 5 is 25. 25 times 16. If I have 16 quarters, I have $4 or 400, right? 4.00, 400. So this ends up giving me 400 x to the fourth. 400 x to the fourth. All right, let's go to the next one. I have this 2x to the third power. 2 times 2 is 4, times 2 again is 8. So this is 8x cubed, right? And then 5 squared is times 25. All right, so let's multiply. 8 times 25. If I have 8 quarters, how much money do we have? That's $2 or 200 cents. So we have 200 times 10. If we have 200 times 10, we just add another 0, and that gives us 2,000. So we have 2,000 x cubed. So plus 2,000 x cubed. What was I thinking giving us such large numbers? All right, so here we go. Then we have 10 times 2x squared. So this 2, the squared goes to both the 2 and the x. 2 squared is 4x squared. So we've got that. 5 cubed. 5 times 5 is 25. Times 5 again is 125. So I have 4 times 125 times 10 that I need to multiply together. Well, 4 times 125 gives us 500. 500 times 10 gives us 5,000. Again, 125 times 4 gives us 500, times 10 gives us the 5,000. Gives us the 5,000. So we have 5,000 x squared. Next term. So we have 5 times 2x to the first power times 5 to the fourth power. 5 to the fourth power is 625. Okay, that's 625 times 2x times 5. Well, guess what? I know that 5 times 2 gives me 10. Multiplying anything by 10 is easy. We just add a 0. So 625 times 10 is 6,250 or 6,250. So 6,250x. 6,250x. And then our very last term, 2x to the 0 power is just 1. And so I have 1 times 5 to the 5th power. Well, I already know that 5 to the 4th power is 625. So what is 625 times 5 again? 5 times 5 is 25, carrier 2. 5 times 2 is 10, 11, 12. Carrier 1, 6 times 5 is 30, so this is 3125 plus 3125. And yes, that did take us a minute to do, didn't it? To walk through that and to listen to me say everything out. However, it was still probably faster than doing 2x plus 5 to the 5th power, multiplying everything out using distribution. But again, this is a preference. Take your pick. And you are always welcome to check your solutions graphing using your Desmos calculator.